Cadets, how are you? Today we are going to discuss our formal class of algebra. Actually, the first chapter is too easy for you to learn from me. I think you already got a good understanding, very good understanding of the chapter. Still, as part of formality, we are going to very quickly discuss the chapter. And before discussing the chapter, we are going to take a look in theory. There are rules, some like associative law of multiplication, which goes something like that, and there is another law, exponential laws of multiplication, which says that if two a's are multiplied by itself, it would be a square, and if four a's, like this, if four a's are multiplied by itself, then we get a to the power 4. And there is a common misunderstanding among some students, which I think you do not have that misunderstanding, is that some students write it like this: if 2 is 2 to the power 2 cube, they write it 6. Obviously they mistakenly multiply 2 with 3, which is not the case. Actually it would be 2 times 2 times 3, which is 8. So I think you do not have that misunderstanding. And we have distributed law of multiplication, which says that if something like this, if 2 is multiplied by a plus b, then 2 is multiplied with a and b both, so we get 2a and 2b. Actually there could be more quantities in that, like this. If m is multiplied by a plus b plus c, then we could expand m and write m with all quantities like this: ma, mb, mc, all added together. You already know this rule, so we don't have much time to discuss this. And also you know this. Now an example which is considered this: 5x square x y to the power multiplied by 3x square y cube. And you know the rule. At first you have to multiply the numbers, so 5 multiplied by 3 is 15, and then you have to multiply common variables. Say here we have x square and here we have another x square, so we have x to the power 2 added with this 2, so x to the power 4, and again y to the power 4 y cube. When multiplied, we get y to the power 4 plus 3, that means 7. So that's how it is, and that is so simple. And without doing anything, we can enter into formal exercises. So what would be the answer to this? How quick can you be? There are two quantities, 5xy and 6az, or in American English z. So we get 5 times 6, 30, and there is 1x, so we have x, there is 1y, and there is 1a and 1z, so we get 30x y az, or if we organize them, it would be 30a x y z. Okay, that's how simple it is. And let's do this: 3x plus 3y plus 5xy. What do we get? We can write it something like this. Let's take a pen, and then we can write 5xy times 2x plus 3y, and we would get 5 times 2 is 10, and there is 1x here and another x here, so we get 10 x square y, plus here we have 3 and here we have 5, so 15. There is only 1x, and here 1y and here another y, so 2y, so y square. That's it. Since this quantity and this quantity, they are different, so we cannot add them. One is x square y, another one is x y square. If they were both x square y or x y square, we could have added them together, but now we have no way to add them. So let's see another example. Consider this: 15 x square 1 plus x square minus 1, x square plus 1 multiplied by x square minus 1. Again we get say x square plus 1 multiplied by x square minus 1. pardon me for this 2, it doesn't look good, whatever. So equal to, what do we get? First let's multiply x square with this whole quantity, so we get x to the power here 2 and again here 2, so 2 plus 2 is 4. Then again multiply this x square with this minus 1, so we get x minus x square. Now this one, multiply this one with this x square, so we get x square, and then this one with this minus 1, so we get minus 1. Then we can, this x square and this x square, they cancel out, and what we get is x to the power 4 minus 1. That's the answer. Let's discuss one last example of today. Which would be, let's discuss this. It says that a equals x square plus xy plus y square and b equals x minus y. Prove that a b equal to x cube minus y cube. So let's multiply them. Without writing that up, let's directly multiply them. If we multiply this whole term with x, then what do we get? We get ax, since there is 2x and there is 1x, so we get x cube. Then xy multiplied by x, we get plus x square y. Then this x multiplied by y square, we get x y square. Then this minus y multiplied by this whole term, we get at first minus x square y, then we get minus x, since there are two y's, so x minus x square, and then finally there are two y's and there is one y, so we got y cube. Now we can cancel out x square y, x square y, they cancel out, and again this xy square and this xy square, they too cancel out. So what do we got? Finally we only have x cube minus y cube. Although this is not the formal way how you write this in your exam script, I think you know that better than I do. So that's it. That's how we can conclude today's class, and you will have some tasks which I will give you as an assignment, and do not post the assignments on the home page. There is a separate section for assignment. Post the answers there. Okay, good luck, thank you.